Hello. In this video, we'll talk about multiplication and division of rational expressions. We saw that we can multiply radicals with different radicands. So when we simplify radicals, so during simplification, we saw that we can multiply radicals with different radicands. Yeah. And what do I mean by that? We saw that if we have square root of 8, that is the same as if we say the square root of 4 times the square root of 2. And then we did this because we said, well, this is the same as the square root of 4 is 2 radical 2. So this process here is we saw that, yes, we can multiply radicals, okay, where the radicand is different. The key is that the index have to be the same, right? Once the index is the same, we can do this. So the process of multiplication is something that we saw before if you looked at simplification of radicals. Well, in this section, we'll look at multiplication and division of expression that contains radicals. As you will see, multiplication of expression that contains radical is very similar to multiplication of polynomials. The division problem in this section is just an extension of work we did previously when we rationalized denominators. So what we do when we are multiplying, right? If I say, example, to multiply, and if I have 3 root 5 times 2 root 7. So it's very important to notice that the index are the same for these radicals. So what we can do is that we can say, we can regroup this if you want to regroup, and you don't have to do it this way. Regroup, and we can say 3 times 2. What I'm doing here, I'm taking what we call generally, we consider the coefficient, okay? And then we multiply the radicals, which is radical 5 times radical 7, okay? So 3 times 2, we get 6, and radical 5 times radical 7, remember, we can multiply from what I showed above here, right? 5 times 7 becomes the root of 35. And that's multiplication. This here is the multiplication process. So if we look at another example, and we have to multiply 4 square root of 6 times 2 square root of 15 times 3 square root of 10. Well, the whole idea is the same. We can regroup, or if you want, you can say we multiply 4 times 2 times 3. So 4 times 2 is 8. 8 times 3 is 24. Okay. And then we multiply the radicals. So we have radical. So let me do this in 2 steps because I don't want to confuse you. This is 4 times 2 times 3. Okay. which is equal to 24. And then we have radical 6 times radical 15 times radical 10. And that is, if we multiply this, we have 6 times 15 is 90. 90 times 10 is 900. So here we have, and this is the root of 900. So our final answer is 24 times the root of 900. And we want to see always, I said, to check, see if you can simplify your answers. 900 happens to be a perfect square. So 24 times the root of 900, if you multiply, so 900 is a perfect square. Okay, because if you multiply 30 times 30, we get 900. So this becomes the square, this becomes 30 times 30, which is 900. So we can just say that this here would be 24 times 30. And if we multiply 24 times 30, that now becomes 720. Okay, so this will be our final result. So sometimes the root can be simplified, and you always have to check to see if you can simplify them. Always check. Okay. Let's look at a different example in the sense where we have to use the distributive property. So example, if we multiply, okay, and we have root 3 times 2 root 6 minus 5 root 12. So here we can use the distributive property. Okay, we can always use the distributive property. So we're going to distribute this times this, and then this times that. And if we do that, if we look, keep in mind there is a coefficient here of a 1. So if we distribute, we get the 1 times 2, which is 2. And then radical, if we do radical 3 times radical 6, that becomes radical 3 times 6 is 18. And then if we distribute again, the 1 times the minus 5 is minus 5. Okay. And if we multiply 3 times now the 12, that becomes the root of 36. So always look inside the radicand. Notice that this here can be simplified, and 36 is a perfect square. So we can simplify this as 2, and the root of 18 can be the root of 9 times the root of 2. Okay, because 9 times 2 is 18. Minus 5 and 36, the root of 36 is 6. So this here is a perfect square. So we now have 2 times 3 root 2 minus 5 times 6. And 2 times 3 is 6 root 2 minus 5 times 6 is 30. And here is our simplified answer. Okay. So the multiplication process, is kind of varies from problem to problem, but it's very similar to multiplying polynomials, because here, whatever in the outside of the parentheses, we distribute to the inside of parentheses. Similarly, you will see if I ask you to multiply, and I have two binomials. For example, the root of 3 plus the root of 5, that's one binomial, times 4 root 3 minus root 5. Yeah. So we know that when we have binomials, we generally say we FOIL them, right? We FOIL them. So if we FOIL, we will multiply here by FOILing, or let me rewrite here, the root of 3 plus the root of 5 times 4 root 3 minus root 5. If we FOIL, we will multiply root 3 by 4 root 3. And if we do that, we will get 4 root 9, because there's an invisible here. The 1 times the 4 becomes 4. Okay? And then root 3 times root 3, it becomes 9. If I use a different color, okay, this now times this, that's the first one was the FOIL, F, and now we have O, right? If I multiply these two, this becomes minus this 1 times this invisible 1 becomes 1. Okay, if I multiply those two, we get minus 1, and root 3 times root 5 becomes root 15. Okay, if I use a different color so you see what's happening, now I multiply this, the inner terms. Okay, the inner terms. So this invisible 1 here, 1 times 4 is positive 4, and root 5 times root 3 becomes root 15. And then finally, this times this, which is the last term, okay, this becomes minus, let's use a different color. Let's use blue. This times this becomes minus 1 root 25. Now I look to see if I can simplify and combine like terms. Notice that the radicand and the powers are the same, so these are like terms. Okay, these are like terms. So we have 4 root 9 plus 3 root 15 minus root of 25. There's no need to write that 1 there. Okay. So because they're like terms, we just add and subtract the coefficients. Now notice that over here, 9 is a perfect square, 25 is a perfect square. So this becomes 4 times 3, because this is 3, plus 3 root 15 minus 5. And 4 times 3 is 12, so we have 12 plus 3 root 15 minus 5. And here we have like terms again. Like terms. So finally, if we do this, we have 12 minus 5, which is 7, plus 3 root 15. And always check, can you simplify that radicand? And since we cannot, the final answer is 7 plus 3 root 15. Now be careful not to add the 7 and the 3, okay? Because there is no root next to the 7. It has to be a square root, so you can't add them, and it has to be like terms. So these are not like terms. Okay. So here we multiply two binomials. Okay. We can look at another example of multiplying two binomials. So let's look at another example. Let's multiply root 3 plus root 2 times 3 root 3 minus root 2. So once again, I can rewrite it and FOIL it out because they're two binomials. Yeah, they're two binomials. So if we multiply first this times this, that's my first term, we're multiplying that. And if I multiply that, that becomes 3 radical 9. Yeah, 3 radical. Then using a different color, so you see this times that, which is the outer terms, that becomes minus root 3 minus root 2 becomes minus root 6. If we use another color, the inner terms now, inner terms, so this becomes, it's going to be a positive 3, okay, root 6. And then finally, if I multiply the last term, we get minus root 4. 2 times 2 is 4. So notice again, we have like terms. So I could combine those two like terms, give me 3 root 9, and a minus 1 plus 3 becomes plus 2 root 6 minus root 4. And notice that we have here perfect squares. So those can be simplified. The root of 9 we know is 3, and the root of 4 we know is 2. So this becomes 3 times 3 plus 2 root 6 minus 2. Okay. 3 times 3 is 9. So 9 plus 2 root 6 minus 2. And then once again, we have some like terms. So finally, we have 7 plus 2 root 6. Okay. Here is our final answer. So multiplication, once again, I'll stress, follows the same principle of multiplying polynomials. And here's another example where you will see that example. If I say multiply, okay, and I have root x plus 3 quantity squared. So we can multiply, we can rewrite this. We can rewrite it because we know the square here means you have to see the parentheses twice. Okay. So we have root x plus 3 times root x plus 3. Okay. And then if we FOIL this out, just as we did before, root x times root x becomes root x squared. Okay. Or becomes root x times root x. And then if we do this again, root x times 3 becomes positive 3 root x. Now we move to the inner terms. 3 times this becomes plus 3 root x. And then finally, we have 3 times 3, which becomes plus 9. So we know that the square root, if we square it, this just becomes x. Okay. Here we have like terms. So I'm gonna skip a line there. X plus 6 root x plus 9. And here there's no like terms for us to combine, so that's our final answer. You always look to see if you can combine like terms. So there's no other like terms here to combine. Let's look at another example. if we have 3 root x minus 2 root y quantity squared. Yeah. So if we rewrite this, this is the same as 3 root x minus 2 root y times 3 root x minus 2 root y. And we FOIL it out. Or if you want, you can apply the expansion formula, the first term squared, then 2 times the first and the second term, and then plus the last term squared. So you can do that if you want. Okay. And I'll show you that in a minute. So if you multiply this out, 3 times 3 becomes 9 root x squared, right? Because root x times root x becomes root x squared. And then we multiply again, 3 times the next term, so that becomes minus 6 root x times root y. They're not like terms, or you can write root xy if you choose to. And if we multiply now this times this becomes minus 6 root x times root y. And then finally, this times this becomes minus 4 root y quantity squared. Okay. Combining, these are like terms. Those are like terms, so that becomes, I will leave the first 9. We have 9 root x squared minus 6. Minus 6 becomes minus 12 root x root y minus 4 root y quantity squared. Now we know that this here is the same as x, so this becomes 9x. We can multiply these two, so minus 12 root xy. Yeah. And this is the same as y, just like how this was the same as x, so we have minus 4y. And I think I have a minus times a minus should be a plus. Okay, should be a plus. When you multiply the two last terms, we have a plus there. Okay, now I said that we could have applied the formula. So alternatively, if I ask you to multiply, okay, and we have 3 root x minus 2 root y squared, we know that when we have a square, we can apply the formula for square of difference, right? If you recall, when you multiply polynomial, if you have a polynomial a minus b squared, this is equal to a squared minus 2ab plus b squared. Okay, so you take the first term and you square it. Then you multiply the two middle terms by 2. And then you take the last term and you square it. Okay, so the first term in this polynomial here, with the one with the radical, 3 root x minus 2 root y quantity square, this is my first term. So we take 3 root x and we square it. And then minus, since this is a minus, 2, always 2. And then we have 3 root x times 2 root y. Okay? And then plus the last term squared. So 2 root y squared. Now, this really means here 3 squared root x squared, right? Because you have to distribute the 2 to everything. So this is 9 root x squared, and root x squared is just x. Okay. If you multiply the coefficients, 2 times 3 is 6, 6 times 2 is 12. So 2 times 3 times 2, and then you have root x times root y. So this becomes 2 times 3, 6 times 2 is 12 minus root x root y, which we know is the same as minus 12 root xy. And then this here plus 2 squared root y squared becomes plus 4 root y squared, which is the same as 4y. So notice that this answer is the same as the answer we had above, right? 9x minus 12xy plus 4y. So you could apply the formula if you choose to do so. It's not, anything bad about it. That's always something you can do. Now, in my next example, if I ask you to multiply root 6 plus root 2, and then we have root 6 minus root 2. So notice that this is the difference of squares, right? Notice that this is difference of square. These are exactly the same, except the signs are different. And we know, if you recall, if we have a minus b times a plus b, that is equal to a squared minus b squared. Yeah. So it's the first term squared minus the second term squared. So if we have the square root of 6 plus the square root of 2 times the square root of 6 minus the square root of 2, this is my first term, so it's a square root of 6 squared, always minus the second term, square root of 2 squared. Okay? And by doing this, the square and the square root will cancel out. So this becomes 6 minus 2, which is equal to 4. And you'll notice that if you FOIL it out, the middle terms will cancel and you will end up with 4 anyway. So you could either FOIL it out or not, okay? So once again, I'm going to stress that the multiplication process is really the same as polynomials, right? When you multiply radicals. Now, the division that we're talking about, the division is where it comes to rationalizing. So in my next example, yeah, if I said divide 6 divided by the square root of 5 minus the square root of 3, and what I'm really asking you to do here is rationalize the denominator. And remember, rationalizing the denominator means write your denominator without a radical or without a root. Okay? That's what it's basically saying. Write it without a root. Okay? So if I do this, I multiply by its conjugate. So 6 over root 5 minus root 3. We will multiply by its conjugate, which we know is the square root of 5 plus the square root of 3. And we have to do top and bottom because if you divide it, this is just 1. Okay? It's only 1. So notice that the bottom is difference of squares, right? The bottom is difference of squares. So by multiplying out the bottom, you will get the square root of 5 squared minus the square root of 3 squared. And anytime you multiply by the conjugate, you will notice that that's happening. In the top, if we multiply this out, so 6 times root 5, okay, becomes 6 root 5, and 6 times root 3 becomes plus 6 root 3, okay? So the top stays the same, but the bottom becomes the square root of 5 square is 5 minus the square root of 3 square is 3. So finally, this becomes 6 root 5 plus 6 root 3 over 2. But notice that we have a common factor, right? Or we can think of this as 6 root 5 over 2 plus 6 root 3 over 2. Or if you want, you can say from this, stay here, factor 6. So if we factor 6, that becomes 6 times root 5 plus root 3 over 2. And then notice that the 6 and the 3 can be simplified, so that becomes 3 root 5 plus root 3. And notice that if you did that here, okay, the 6 and is divisible by 2, so you get 3 root 5, and the 6 here is also divisible by 2, okay? So you get plus 3 root 3. And if you distribute it or you factor out the 3, you get the same answer, okay? Because if you multiply here, this is the same as 3 root 5 plus 3 root 3. So you get the same answer regardless which way you write it. They are the same answers. So it's just a matter of choice, whichever way you choose to do this. Yeah? Whichever way you choose to do it, it's your choice. Let's look at one more example. Let's rationalize the denominator. Okay. So we have root 5 minus 2 over root 5 plus 2. So if we're rationalizing the denominator, it means to write this where your denominator doesn't have a radical. So we'll multiply by the conjugate of the denominator, okay? The conjugate of the denominator. And the conjugate of the denominator would be root 5 plus 2. And we multiply the top by the same. Root 5 minus 2, because this is a plus. If this is a plus, that has to be a minus. So if that's a minus, then we get root 5 minus 2. Top and bottom, we multiply by the same, because when you do the division, it has to be 1. Now this is difference of squares. So if you multiply the bottom, we will get root 5 squared plus 2 minus 2 squared. Yeah? And multiplying out the top, if you FOIL the top out, we have to multiply the top. So 5 times 5 becomes the root of 25. Then 5 times minus 2 becomes minus 2 root 5. And then we multiply the next term. So this becomes minus 2 root 5. And then minus 2 times minus 2 becomes plus 4. Okay. Notice that your two middle terms are like terms. So we have, and the root of 25 is 5, so this becomes 5 minus 4 root 5 plus 4. And in the bottom, root 5 squared is 5, and root 2 squared, no, just root 2. 2 squared is 4. So 5 minus 4 in the denominator, which is just 1. And in the top, we have like terms. 5 plus 4 is 9 minus 4 root 5 over 1. We don't need to write it over 1, so this is the same as 9 minus 4 root 5. And here is our final answer. So notice we're just saying to rationalize here the denominator, right? There are cases where you can rationalize numerator too, if we say so. And all it means is to write the numerator without any root. So as always, I usually close off by saying, please make sure that you practice more problems of these types so you become better at it. Until next time.